Uitgesnelde?
Thank you. Thank you for joining us, everyone.
Hello. Well, thank you all for coming. We really are happy with this turnout. Thank you all. So we will now actually start the official reveal presentation for Roboteam for the next 10 years. So as you may or may not know, Roboteam has been competing in the RoboCup for the past 9 years, where we created these soccer robots, as you can see here, these little plushies. So for the past 9 years, we have been competing with them. It is now the 10th year of Roboteam, and we decided there needs to be a change to increase our innovation and to really showcase what we can do. And with that, we changed our competition. Before we talk about the competition switch, we wanted to show you our team. So this is a bit of our team photo. Since this photo was taken, we actually have more people joining the team. And we are now the largest Robo team ever with 27 students. And the reason we needed such a large team is to accommodate for the new competition that we'll be attending, which our team manager, Mariah, will talk more about.
Yes, thank you. So, for the past 9 years, as Mariam said, we've been competing in the SSL and it brought us to great places. We are extremely happy with everything that the team has accomplished over the years. Years of innovation and inspiring in the fields of robotics and AI have brought us to this point. And today we're taking the next step. And with our 10-year anniversary, we want to look to the next 10 years. We wanted to choose a competition that suited Roboteam for the next 10 years. Now, what is Roboteam really about? We are a team of students that work together. And the core of our team is an integration project where all parts of engineering come together to create one final product. So for us, that means mechanical engineers, electrical engineers, embedded systems, control engineers, software, AI, and machine learning specialists. All of these people come together to create one full integrated stack. So we're looking for a competition that could accommodate that. We had the choice to stay within RoboCup and go to another competition in RoboCup, but we decided to go to the ERC, or the European Rover Challenge. The European Rover Challenge is a competition where student teams or actually company teams compete to create a Mars-like rover in a simulated Mars environment. This competition is extremely challenging. It incorporates all the things we want for Roboteam. It has all the mechanical, the software, the control, the integration parts, but more importantly, it is very high tech. It is very future. We want to be part of the future industry. We want to push innovation further and expand what we can do as a team, which is also why we grew so much in the team. The competition consists out of multiple subtasks, which are divided among our sub-teams, who all take a part in each subtask and create systems for that. The main parts of the competition are navigation and mapping. It is autonomous navigation. It is going through the Mars yard and mapping out the area. Then we have drilling and sampling. It is collecting samples, doing bioanalysis, looking for biochemical markers, signs of life, and soil composition analysis, which all fall into the science category of the subtask. But all of that is done by having to collect the samples and drill into the ground. Then we have manipulation, which is where you have to manipulate objects in your surroundings. You have to work with a interface that was originally designed for humans and have robots correctly function and interact with this interface. And all these things come together into the European Rover Challenge. Now, our goal for this year is pretty ambitious. We aim to build a platform from scratch and have us competing by the end of the year in the European Rover Challenge. The competition is in August, the first qualifiers are in March, and 1/5 of the slots in the competition are reserved for new teams. So we aim to be the best new team at the European Rover Challenge, and hopefully qualifying through that. Now, I have introduced you to the European Rover Challenge, but obviously we haven't been sitting still for the past 2 months. We've done so much work. From choosing the competition, which wasn't done at the start of the year, that was our team, we did that, to setting up events like this, finding out what we want to do, what we have to do, figuring out all the rules and regulations. Normally you build on your past teams, but we had to find out everything about the competition ourselves. And now I'm going to pass it along to some of my engineers that will tell you about what we've been doing for the past 2 months and show you some of our starting designs. Mirto.
So, sorry. What is a rover actually going to look like? I need the. As Lauren said, we have a very ambitious goal this year, and that means that our engineers, no matter how big the team is, we will need to focus on some subsystems, the most important ones. So, which one are these? We will start with the housing. So now, what is a housing? As it says, it's housing the most important components. It will be the backbone of our robot. Will be responsible for storing all the PCBs, so all electronics, but also for all connections of all other subsystems together. This is a very tedious task, which requires a lot of communication from the mechanical side with other subsystems and vice versa. Then another very important subsystem is a drive system. So the drive system is responsible for getting us around, for a robot to not just be a box, but a box on wheels. This is it seems like a very simple subsystem, but it can get quite complex. In there we can have many of the capacities and the quality of the mechanical engineer shine. It's responsible for smooth moving around the rover in very tight, very complicated terrains like Mars, or the Mars shell we would be going around. Then we have the most complicated subsystems, probably
The robotic arm and its end effector, the gripper, will be responsible for manipulating irregular objects like rocks, but also more fragile objects like probes. And for more precise tasks like the manipulation task that Marijn mentioned before, which will be used for maintenance purposes. Now, everything that the robotic arm will be picking up, manipulating, will be stored into our surface sampling container, which will need to make a precise measurement of the weight of each object that we will be picking up. Now, this bot will also need to provide safe transport to all of these objects, such that our scientists can analyze that later. Now, thank you. Who is doing all that? Our mechanical sub-team. So we are 5 people. We will be responsible for the conceptualization and the design, all calculations, but also designing all the hardware connection between the electronics and also all our subsystems with the hardware, for example, and all their interactions. And we will be also responsible for the material selection, which can be very tedious due to the very harsh circumstances that the marshmallow will have to deal with. And finally, and most importantly, right now we are dealing with the motor selection, which can be quite challenging. And now electronics will tell you a bit more about that and about other electronics that are needed for systems to function properly. Thank you.
Hello, I'm Ernesto, and I'm the Chief Electrical Engineer for this year. For the last 2 months, we have been working in this system. We have here a high level drawing of the whole thing. As you can see, it's divided in a whole lot of different boards, each of them dealing with one of the specific subsystems that the mechanical team explained. The whole point of this is to keep it as modular as we can, because we are thinking in the long term. We are thinking that next year things will have to change a lot of the things that we are doing, and we don't want it to change a big PCB. We don't want it to change a big board. We want to make it easy for them to change the specific parts. And whatever is broken, whenever you break something, basically, you don't want to change the whole thing. This modular system allows you to change the systems part by part. It consists on an external base station, which is going to be the one in charge of sending all the communication between the system and the actual rover. Then we will have a diagnostics or debugging board, which is going to be the one dealing with the human interaction. And then as I mentioned before, all these other subsystem boards, which they are SDM board, which we will buy off the set. And all of them will be in a central internet switch in order to have all the internal communications together. Our goals are to, of course, PCB design, make these boards I was talking about, select the motor drivers for all the motors that the driving systems and the arm are gonna have, dealing with the sensors, that includes gyroscopes, accelerometers, infrared sensors, and all those similar things. Of course, wireless communication, and efficient and robust power distribution, and as I mentioned before, a strong focus on modularity in order to make it easy for next year things. Now I'm going to pass it to embedded so they can tell you more about the internal communication of all these subsystems.
Hello everyone, I'm Nick. I'm the chief of the embedded engineering subteam, and before I start, I will start with one thing. Yes. So our system is mainly responsible for making all of these boards that Ernesto mentioned function. And to do that and to align with the theme of modularity, we're designing a decentralized network of boards. Each board is seen as a node that has a small piece of isolated functionality in it. For example, everything that has to do with the robotic arm will be only on the robotic arm board. In which case you can easily change one of the boards without changing the whole system. To do that, we have created this centralized network that has a very robust communication protocol on top of it, as a way to align the communication with everything, as well as to create an abstraction layer between all of the different boards. Furthermore, one of the main challenges here that we need to deal with is the behavior synchronization of all the different bots. As a decentralized system, there is no main authority that synchronizes all the functionality, which is something that we need to deal with and to need to accommodate for. This is our theme. Again, our part is mainly the centralized network and how that functions, but also the synchronization of the network and making sure all of the parts function as they should. And also the internal communication network through the Ethernet switch and the communication protocol will be designed for the communication in command center. I will give now the mic to our control engineer to talk a bit about control.
Sorry about that. I'm Ege. I'm the chief control engineer for this year. This is our team. And our goal as a control sub-team is designing the controllers. And these controllers will be used in two main places of the rover. These are the drive system and the robotic arm. For the drive system, we need a controller which is robust, that can handle difficult terrain in the competition. And it has to be smooth, as Mirta said, and it has to actually navigate through the path we planned for. We'll be doing this using the sensor that Ernesto mentioned, and the other controller that we'll be using will be on the robotic arm. That one is a little bit more detailed, let's say, because it needs to handle very precise and very small, accurate movements. We need to be able to manipulate panels with it. We need to scoop up our samples. We need to put them in the containers. So the robotic arm. So the control on the robotic arm will be a very challenging part for our sub-team. And in order to do this, we are working together with the software team, which will explain more to you about everything. Software related.
Hello everyone, my name is Dimitro, I'm the chief software engineer. And please meet my team. We are all responsible for being the brain inspiration. We will be telling the rover where to go, how to do it, where to do it, etc. That will be our primary responsibility, but we also have some things we're doing, we would say, on the side. First one of them is working with the base station, which would be like a remote control panel for the rover, so we can see what it's doing from outside the field. And the second extra thing we're doing is processing data from the sensors, because we got the most processing power with the code. And one more thing is that we are making a simulation so we can test all the software before we got the hardware, or even the hardware doesn't work. In the beginning of our first months, the simulation was not working very well. As you can see, the wheels are rotating not as they should, but we are getting better, and we hope that soon the simulation will be working much better. As you can see, we are also working on computer vision, which is one of those very processing heavy tasks from the sensors. You can see these are Aruba codes. They would be our landmarks, so we can see where we are in the field. And thank you for attention. Thank you all very much for coming. Like I said, we are looking to build the next 10 years of Roboteam. And as you can hear from our engineers, we are focusing on modularity so that the next years can use our system, rip the parts out that don't work, and make something better. In this way, we hope with our new competition, with our new partners, with our old partners, to create the next 10 years of Roboteam. Thank you for joining. Thank you guys. Thank you.